Welcome back. I had a weird situation there. I was getting the message that my internet connection was unstable and things were kind of getting a little glitchy. So I just stopped and decided to. It's kind of good too because I think the first part's already 25 minutes. So let's call this part two, and then there will be a part three. So um, at least they're split up a little bit. Okay, I'm going to continue where I left off with the AP question we were about to talk about. Um, the function f is differentiable on the closed interval of -6 to 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments, as shown in the figure above. On what intervals is f increasing? Justify your answer. Okay, so I had recreated the chart when I think everything was going kind of haywire. So I recreated the bit of the chart that we need. The key to this problem is this is the graph of f prime. So if you have the graph of f prime in front of you, then that would mean that if you're looking for intervals of increasing, you need to know where it is positive. Okay, so we are going to, that's how many times I redo that and that. Positive, right? So f is increasing on -6 to -2 and from 2 to 5 because f prime is positive. Okay. All right. The next question, or the next page, finding local extrema. All right, so officially first derivative test. Let's talk through this. Suppose that f is continuous on an interval that contains a critical point C and assume f is differentiable on an interval containing C. All right, differentiable, continuous and differentiable. If f prime changes signs from positive to negative as x increases through C, then f has a local max at C. If f prime changes signs from negative to positive as x increases through C, then f has a local minimum at C. If f prime does not change sign at C from positive to negative or vice versa, then f has no local extreme value at C. This is all in material we've talked about already, meaning we just haven't pinpointed it yet, but we've done all of this. We've done the sign chart and we've seen where things are changing from positive to negative when we talk about intervals of increase and decrease. So we're going to put it all together now and then talk local maxes and mins. Okay, so this idea of a first derivative test we've seen. We're going to find the critical points. We're going to set up our intervals using our critical points in domain. We're going to use the test points in each interval using the derivative in its factored form to determine if the derivative is positive or negative. And we're going to look for where the derivative switches signs. Guess what we've done? We've done this. So if I scroll back really quickly to all of our previous examples, what this is saying is now that we've done this and we see the change from positive to negative, technically that's our critical point. So that would mean that we have a relative max. We're going from increase to decrease at 1. Here we're going from increase to decrease. That's a relative max. And here we're going from decrease to increase. So that would be a relative min right there at 0. Here we would have relative min as well, going from decrease to increase. All right. So let's do this. Let's try one of these problems. So we start like we do with everything else. We're going to find critical points. When I look at g of x, I think to myself, okay, I could use product rule, but I could also distribute, which I'm going to do because I think distributing will make this easier. And this is 2/3 plus 3/3, so that's 5/3. So now I'm going to take the derivative, and that would be 4/3 x to the negative 1/3 minus 5/3 x to the 2/3. And I am going to factor this. I'm going to factor this for my critical points. So to factor this, I would take out a common 1/3 x, and then to what power? I would take it, remember smallest, we did this at the very beginning of the year, to the negative 1/3. You still choose smallest. You can't take more than you would have in any one of them. What ends up happening? Well, with the first term, it's easy enough. It's just a 4. 4 times 1/3 x to the negative 1/3 is that. Now, I definitely need, get my pen back, I definitely need a 5. That would give me my 5/3. To make x to the negative 1/3 multiplied by an x term, that would give me 2/3. How's x to the 3/3? In other words, x to the first. This is much easier, right, to use in this form than I think product rule would have resulted in. So my rewrite on this could look like this. And I'm doing that for purposes of, for critical points, remember, it is where you are either undefined or equal to 0, right? So critical points. So the equal to 0, 4 minus 5x equals 0, would give us a critical point of 4/5. 4 equals 5x, right? And if I were doing, it's not going to equal 0, but guess what? F prime, G prime, sorry, changing the name of my function here. G prime is undefined at x equals 0. This cannot be 0. So our critical points are 0 and 4/5. Zero and 4/5. So now we have to look for, again, our sign changes. So if we pick something less than 0, plug it into our factored form, if you will. Right, something less than 0. So if I did, let's say, negative 100, or even negative 1, negative for this, right? Negative for right here. And then if I plug in a negative 1 and or negative 100, right? This is going to turn positive right here. So that's actually doing that positive. So overall, a negative times a positive is a negative. Something between 0 and 4/5. 4/5 is 0.8, right? So how about a half? So again, we're with positive on that first term. And then if we plug in a half, 4 minus 5/2. Think about that. That's 2.5, right? So that's still positive. So this is positive. And then larger than 4/5. Okay, you go to 1 or you go to 500. Doesn't matter. So if I plug in something larger than 4/5, I am again positive, and I am negative. If I plug in 1 for x, 4 minus 5 is negative 1. If I plug in anything larger than 1, I'm still going to be negative for this. Okay, so overall, negative interval. What does this mean as far as maxes and mins? Well, as far as maxes and mins are concerned, actually I'll do, remember that decrease? No, that's not going to show up so pretty. So let me go back to my lighter green. So decrease to increase, right? Increase to decrease. So if we change from decrease to increase, we're going to have a local min. If we change from increase to decrease, we're going to local max. So now we just need to write all of that out. And I'll do, sorry about the changing of the colors, just so it stands out a little bit. So we have G has a local min at x equals 0 because G prime changes from negative to positive. And then we can say G has a local max at x equals 4/5 because G prime changes from positive to negative. And it is not enough to say changes signs. That is not specific enough. How do you know you have the max? You have the max because you're going from positive to negative. How do you know you would have the min? Because you're going from negative to positive. Okay, for the next question, it says that we have a calculator question. So I'm going to pause to get everything set up for the calculator, but you probably won't even notice the difference, but we'll see you in just a bit. Okay, we're back. Hopefully this is actually working. So the next question is a calculator question, okay? Function f is defined on the open interval from 0.4 to 2.4 and has a first derivative given by f prime equals sine x squared. So find all values of x at which f has a relative extremum. Determine whether f has a relative maximum or relative minimum at each of these values and justify your answer. All right. So again, they're telling you f prime. That's f prime, right? So that means that we're going to use the calculator, and I'm actually going to plug in f prime into the calculator. And I already put that into y equals. And we have to remember again that f prime, forgive me for adjusting my, so used to now using my iPad, that I'm a little less practiced with my dot camera. So again, remember that f and f prime, as far as relationship is concerned, right? So if we are given f prime, we're talking about relative maxes and mins, we're looking at sign changes on f prime. All right, so sign changes on f prime. First thing I would suggest is to go to, I'm resetting the window purposely because I'm going to show you a couple of things that I'd like you to do. So I went to Zoom 6 real quick, but I want to show you a couple of things. In y equals, I'm specific to this domain, 0.4 to 2.4. I am actually going into the window and I'm going to do 0.4 to 2.4 as my x values. Now, one of the Zoom functions in the calculator that works nicely in most situations is Zoom fit. The other thing I should have said at the beginning of this, radian mode for sine, right? Radian mode for any trig values that we have. So make sure you're in radian mode. I know I'm in radian mode, but please pause to do that real quick. But as far as a Zoom function is concerned, something called Zoom fit will then, after you've, I scrolled really to get there to zoom in 0, so you can hit the zoom key and just the 0, but it will basically adjust your y values accordingly without you having to do that. So you set the domain and then the calculator itself will set the y, okay? So again, if we're looking for relative maxes and mins, we need to know where we have changes in our derivative graph from positive to negative. So that would mean actually we are just concentrating on right here because we already set the domain for ourselves. This is where that sign change happens. And what kind of a sign change is it? Positive to negative. Okay. So I need to find the 0. So second, trace function 2 for 0. So on the left side, I might try to mess with something really fast before I is it that one that worked. I had it really nice yesterday when I was practicing a little bit that I had it come out very clearly, but it seems to have lost a little bit of its pizzazz. It's not coming out as great as it was before. So left side of your 0. So I apologize for this, but right here is where I'm crossing the x-axis. So I just want you to see this part right there. So I am on the left side. I'm going to hit enter. And then I'm going to right arrow and go down to the left. And again, I'm going to put the pen across there as my x-axis. So I am on the right side. Okay. And then you hit enter. You don't have to guess, but your 0 is at 1.772. Okay. So your critical point is x is approximately 1.772. So that means that F has a relative max at 1.772 because F prime changes from negative positive to negative. Changing my technology has thrown me off, so I apologize. And that is it because there is nothing else occurring sign change wise. Okay. All right. We're going to pause one more time and I am going to go back. All right. And we're back. I just wrote down what I had written down on my hard copy paper that F has a relative max at 1.772. So prime changes from positive to negative. All right, the next type of problem we are going to go over is a table problem. Okay, let F be a function that is continuous on the interval from 0 inclusive to 4 non-inclusive. The function F is twice differentiable except at x equals 2. The function F and its derivatives have the properties indicated above in the table, where D and E indicates that the derivatives of F do not exist at x equals 2. For x between 0 and 4, find all values of x at which F has a relative extremum. Determine whether F has a relative maximum or a relative minimum at each of these values. Justify your answer. All right. Right, so beginnings of the table. And we are right here. So we would be looking for F prime. Right, we're looking there and we are looking for, if we're looking for relative extremes, then we need what? F prime being equal to 0 or undefined to begin with. So let's see. I see that. I see that. Okay. We also need what? A sign change. We need sign change. So here on either side of 0, I've got positive and I got positive. That's not going to do anything. It just means that F is increasing there. We might have something happening at 1 that's like that, right? But at 2, it's not defined at on the derivative, but the function is continuous there. Could be a corner or a cusp, but we go from positive to negative, which means that we would have an increase to a decrease happening, which means we have a local maximum. So at critical points are x equals 1 and x equals 2. Okay. Because f prime equals 0 and f prime undefined respectively, right? At x equals 1, there is no relative extreme. Because there is no sign change on f prime. At x equals 2, there is a relative max because f prime changes from positive to negative. So it says at each of these values, they wanted you to name them anywhere it was possible, and they wanted you to explain each one of them. Okay, critical points are x equals 1 and x equals 2 because f prime is equal to 0 and f prime is undefined, respectively. At x equals 1, there's no relative extreme because there is no sign change. And then at x equals 2, there is a relative max because f prime changes from positive to negative. Next, a graphing problem. All right, let f be a function that is defined on the interval -4 to 4 inclusive, shown as the graph of f prime. At what x values does f have a horizontal tangent line? At each of the x values you identify, determine if the x value is a location of a local min, max, or neither. Justify your answers. All right. That means what? F prime equals 0. Okay, and we are given f prime again. Okay, so you need to identify the x values where this could possibly happen and then talk about all of them. All right, so pause, do, and then come back. Okay, so what do we need to find first? All those places. So we are here, 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 and here. That's all those places that x is equal to 0. Right? So f prime at x equals 2, 2, 6, and 10. Okay. All right, so if we start to talk about each one of them, probably a line about horizontal tangent lines happen when f prime is equal to 0. So let's see what's actually happening here. So possibilities are all 4 of these. Now let's talk about each one. So at x equals -2, do we have a sign change? We sure do. We go from negative to positive. So at x equals -2, f has a relative min because f prime changes negative to positive. Let's look at 2. Nothing. All right. I'm going to save the no sign change ones for last to write about those. Let's look at 6. 6, there's a definite sign change. We go from positive to negative. So at x equals 6, f has a relative max because f prime changes positive to negative. Okay. And then again, 2 and 10, we don't have a sign change. At x equals 2 and relative extremes. And that does it for this particular part of 4.2. There will be one last video on 4.2. See you soon.